Welcome to Unit 4. This is the unit that we are going to be covering linear functions. And before we go too far, what you need to understand is a lot of this stuff you've covered already. Today we're going to be covering the notation that we're going to be using, different types of notation. It's more of a review, as well as what we call average rate of change or slope, which is things you've seen or should have seen before you enter this class, but it's a good review. Take your time to familiarize it with this unit. So I'm going to have you pause the video now, read through the problem, try to answer questions A and B. I have my solutions covered, and then we'll uncover them here. Hopefully you've had time to do that. So what I'm going to do is I'm going to scroll this down. We're looking first of all for part A. If you consider the function t equals g of m, interpret the meaning of g of 0. G of 0 is simply the temperature at noon, which is 65 degrees. Don't make it any more complicated. It says up here, T is the temperature and M is the time. So temperature as a function of time. So you can write it G of M or T, each one works. But if you're looking for G of 0, that's just what is the temperature at time 0. So if we want to evaluate that and you put this in context, 45 minutes into the assembly, this is what G of 45 stands for, which is 77 degrees. And if you look up here, it stays that way for the first hour. So you're going to have 77 degrees up to the first hour. Every minute after that hour, when everybody leaves, it's going to drop down by a degree per minute. So over the next 5 minutes, it will drop down by about 5 degrees. So this is just familiarizing yourself with the notation. So it won't always be y equals or t equals. Sometimes you can do g or x or f of x. Either way, that notation should be known. You should have used this before. This formula down here is what we call the average rate of change formula. And the average rate of change formula, change in y over change in x, or if you want to use the notation we're using right now, we have the g of b, g of a over b minus a. So if we're looking for, from the beginning to the end of the assembly, how much did it change, what we're going to look at is, at the end of the assembly, it was 77. The beginning of the assembly was 65 degrees. And that occurred from 1 o'clock until noon. So this on the bottom was just simply 1 hour. How much did it change from beginning to the end of assembly? So it changed 12 degrees in 1 hour, or 12 degrees per hour. And that's how you use your rate of change formula for that. Let's try another rate of change formula because that one was overly simplified. Take a minute, look at this one, see if you can pause the video, come up with what you have for your formula. And I'll write down, again, average rate. And see what you come up with. See if you came up with the same thing I did. Okay, so we're looking at when does the temperature increase or decrease, or sorry, in this case, decrease the fastest. We're looking for the fastest rate, so we want to calculate the two rates. So let's look at the rate between midnight and 3. So the average rate between midnight and 3 is, it started at 85, went down to 76, and it did that in 3 minus 0 hours. So this will give you 9 divided by 3, or 3 degrees per hour. And that's the average rate for midnight to 3 a.m. If we want to do the average rate between 3 and 4, it would be 76 minus 70. It drops 6 degrees, but it did that in only 1 hour. Or in this case, 4 minus 3. Sorry. So the question is, in which section between midnight and 3 or between 3 and 4 did the average rate decrease the most? And your answer is between 3 and 4. So notice between 0 and 3, or between noon and midnight and 3 a.m., it went down 9 degrees, but it went down 9 degrees in 3 hours, which is really 3 degrees per hour, versus going down 6 degrees in that 1 hour, which is 6 degrees per hour. So you can't just look at the temperature, you're looking at the average rate of change. This is how you use the average rate of change formula. If we wanted to do one other problem, what would be the average rate of change between midnight and 4 o'clock? You could do that problem as well. And that average rate would be 85 to 70 degrees over midnight to here, which is 15 degrees in 4 hours, which is 3.75 degrees per hour. So this is how you use your average rate of change formula. Hopefully this makes sense. Good luck with your work, and let me know if you have any questions.